you have to update a model.
Correct.
So this is the model, right? So what does it say? Formula is equal to dot tilde 1. So it says regress participation here
Okay.
on tilde is the list of independent variables.
Okay. List of independent.
Yeah, tilde, beyond tilde you have to give the list of independent variables. If you put just a dot here, then everything.
All the variables.
All. If you put just a 1 here,
First variable.
then only the constant,
Yeah, which is the constant.
which is a constant, right? So this is the restricted model, this is the unrestricted model. Yeah. 0 or 1.
So we are modeling the probability of whether that will happen. So how do you figure out how accurate that probability is? Like R square?
There is no R square, but there are other measures of goodness which I am coming to. Okay, so how correct are we? Right, but there are other measures of goodness of fit, evaluating the performance of the model. There is something called a model chi-square, this is a percentage correct prediction. Okay, what is the model chi-square? You take the log likelihood of the model only with a constant, you take the log likelihood of the model with alpha and beta, so restricted minus unrestricted into 2 minus 2, that is the likelihood ratio test, right? So you take the likelihood ratio test with I degrees of freedom because I is the number of independent variables you have dropped out. So use the model chi-square statistic to determine if the overall model is statistically significant. But what you can do is, the percent correct prediction statistic assumes that if the estimated P is greater than or equal to 0.5, then the event is expected to occur and not expected to occur otherwise. So I will do one thing. For example, from the fitted model, if I put in Siddesh's variables, income, education, etc., then my model says that the probability that Siddesh is employed is 0.7. So I say, okay, Siddesh is employed, so I code Siddesh as 1. Then my model says probability that say Aniket is employed is 0.2. So I say less than 0.5, so I say Aniket is unemployed, so I put it 0. So I get a 1, 0, but in fact Aniket would be employed and Siddesh could also be employed. So I will be wrong in 50% of the cases and right 50% of the cases. My percentage correct prediction is 50%. Okay, so what I do is, in my model, by assigning this probability 0, 1 and comparing those to the actual zeros, 1s, we can form the correct scores. How many times are we correct? Okay. In our model, for example, you see that 300, in general, among the zeros, right, okay, these are the people who are true zeros, 359 plus 179. These are the people who are true ones. Now people who are true zeros have been correctly specified as no 359 times and wrongly classified as yes 179 times. People who are actually employed have been wrongly classified as employed at 112 times in 112 cases and correctly classified as employed in 222 cases. When you use a 50% cutoff to classify 1 and 0. So 33% cases are wrongly classified. Who are the cases wrongly classified? This plus 112. 179 plus 112 are wrongly classified. 359 plus 222 are rightly classified. So 67% of cases are correctly classified if you use a 50% cutoff. But you might wonder why use a 50% cutoff? Why not use a 60% cutoff? So what we are going to do next is we are going to use different levels of cutoff, do this calculation for each level of cutoff and see which cutoff gives me the most correct predictions. Okay. This is called the ROCR curve, the receiver operating characteristic curve. Okay, so this is the ROCR. Okay, I've done it like this. So there is a library called ROCR which I have downloaded the library. Receiver operating characteristics curve. Okay, right? So we have the cutoff. As you correctly see, At about 45% of the cutoff, around 41, 42% of the cutoff, you get the best accuracy for the model. So perhaps you can classify people into employed or non-employed. You classify a person as employed if the predicted probability from the model is greater than 0.41. Whichever value here is on the x-axis, right? So we know that there is various kinds of problems. Omitted variable bias is there, irrelevant variable bias is there, functional form problems are there, multi-cognitive problems are there, structure break problems are there, etc., etc. Okay? But this doesn't really help you. All these models, I mean, these problems you have to simply live with. If you are taking the logit, no, it will generally not be. In fact, you can also show that if you take the wrong likelihood function also, in general your estimates will still be consistent. They can be biased, but they will still be consistent because of the good old law of law of large numbers. Right? You can actually argue that. That's called quasi-maximum likelihood kind of estimates, where you don't get the functional form exactly, but you still get consistent estimates, right? So that is what really the no, in the in sample, not out sample, because it says I have this data. You can do an out of sample prediction also. So another way of doing this is to, if you have 100 observations, do this model only on 40 data points, and then the remaining 60 you try and classify, then check, right, how well your model classifies depending upon this. So you choose, for example, that 0.65 cutoff at 0.41 or whatever cutoff, and then you use that to keep a certain sample as an out of sample model, and then work on that out of sample model. So for example, if I tell you now to suppose you are working for a bank, okay? Suppose you are working for a bank and your objective is to, and suppose the bank has asked you to find out credit risks. So whether people will be, whether a given individual be a defaulter or not a defaulter, right? How will you go about that? How will you go about solving this problem? Suppose you have got a lot of data, the bank's given you data, the bank wants you to find out how do you predict whether if a particular person comes to me for a loan, or I give a credit card to a particular person, what is the chance that for this particular person my credit card will become an NPA, will become a non-performing asset? How will you decide that? So what is the kind of data that you look for, what kind of specifications you will have, and what will you do? Okay, but what will be the Y variable? So you will require data on people who have defaulted in the past and people who have not defaulted in the past. So you will ask the bank to give you a list of the borrowers, given that some borrowers are defaulters. If the bank says, I can't give you data on defaulters, I can give you data only borrowers, then clearly no way you can do this because you can't code your Y 1, 0. All Y's will be zeros. So the bank gives you 1, 0. You code your borrowers as 1, 0. Then you think of some explanatory variables, income, jobs, whatever kind of employment and all those kinds of things. Then you run a logistic regression. Then within that sample, you decide an optimal cutoff using the ROCR, right? ROCR operating curve. And once you know that if the predicted probability is above something, this is the best cutoff for predicting a person as a defaulter, then when a new borrower comes to you, your computer feeds in the relevant information, a p hat is generated from the model. If the p hat is above the classification given by the ROCR optimum, you say that this person is likely to be a defaulter. Otherwise the person is not likely to be a defaulter. Okay, right? Now, if you do this a little bit more finer way, that is, suppose you are interested in whether a person will be a good credit risk, a low credit risk, or a moderate credit risk, or a high credit risk, then you have to rate those people as 1 to 3, where you will have an ordered probit model. Okay, we'll look at an ordered probit model in the next class, right? We have an ordered probit model. Okay, right? Sure? So that's how you will. Can you tell me more applications of this?
Any binary.
For example, I want to find out, I think there's some critical issue that you're interested in. Some sectors have large NPAs currently. That's a big problem that the government is facing, right? Your argument is that housing, that is construction, okay, construction and roads are the sectors where there are the largest NPAs. But you just can't say that a firm, because it's a construction firm, or a firm because it builds roads, is just by that very fact will have a larger NPA. A lot of other things will depend, right? With the firm's board and firm's history and all those kinds of things, right? How strong the firm's balance sheet and a lot of other things will matter, right? So how will you develop, how will you test this hypothesis? That what's happening, that NPAs are primarily, okay, that firms which are in the construction sector or firms which are building in the road building sector are likely to have higher NPAs compared to firms which are in other sectors, for everything else remaining the same. How will you test this hypothesis? So you'll have data on NPAs, right? So you'll have data on credit. You'll know whether a loan has become a bad loan, which will be 1-0, bad loan, or has been restructured really, because restructuring is another way of really hiding bad loans now, 1-0. Then you'll have all the explanatory variables like the balance sheets of the firm and the loan amount taken and so on and so forth. And then you have a dummy variable which will be 1-0, like the foreign, yes or no, to say whether a firm was in the construction sector or the road sector or in any other sector. And then you want the coefficient of the road or the construction dummy to be statistically significant, not 1, statistically significant and positive, right? And then you will say that yes, if you are in the road or the construction business, you are more likely to be an NPA compared to anything else, right? Yeah, suppose you wanted to study, if I ask you a question, how much does smoking raise mortality? By how much does smoking raise mortality? How will you answer this question? Will you collect data on smokers for this? Will you collect data on smokers? All people pass data on people who have died. But can you take data on all people who are dead?
No, but you put a binary variable, smoker or no smoker. You get data on deaths in a particular region, and you will have explanatory variables as to why the death occurred.
How will you get this? This is an interesting question. We are saying how much does the fact of smoking increase the probability of dying? What will you get on 0? That's will you look at all smokers who are around you? But if they are not died, then there is no point. You can't do that, right? Because everything will be 1. So what will you do?
People who have died before 50, or we take it on people who have died before 50. And then...
Or will you... But number of deaths from where? No, but if you have people, but how do you then decide? you'll have to then all that data will do number of there were 100 deaths in this hospital, 50 deaths in this hospital. You'll be comparing the variation in deaths. How do you know about the smoking variable? No, but then you'll have to, this data will be, the units will be across hospitals, right? So the smoking data will also, so you'll have to think of, out of these 100 people who died in this hospital, 70% were smokers, 20% were smokers, right? But that will not tell you how much. Anybody for tea? Anybody else? No? Okay. Yeah? But all your Y's will be 1 now, no?